Good day to everyone and welcome to today's webinar, Measures and Procedures to Prevent Quality-Related Issues During DCU Plant Commissioning and Startup. Thanks to RefComm and Becky Peterson for providing this great opportunity. My name is Vahya Vetisyan and our company, VV-Inex Group, provides QA/QC services for oil and gas, petrochemical, mining, and power generation industries. Our primarily focus is on vendor and site QA/QC activities. And our projects also include risk-based inspection, vendor expediting, supplier audits, project management consulting, and certification. Our headquarters are in Mönchengladbach, Germany. We have also operating offices in St. Petersburg, Russia, and Yerevan, Armenia, with qualified field personnel in 30 countries throughout Europe, Middle East, and CIS countries. And we have more than 20 years of experience being involved in more than 30 projects worldwide. Today's discussion topics, we will talk about different approaches to project QA/QC organization affecting final results, DCU major equipment and specifics in regards to QA/QC activities. We will discuss about QA/QC matters and what is affecting on proper operation and asset integrity, and prevention measures and procedures, Goldilocks approach, and of course, Q&A session. We will have about 30 to 35 minutes of presentation and we'll leave 30 minutes for Q&A session. Quality-related issues. Each project starts with the goal not to have any QA/QC related issues which delay or complicate the final commissioning and startup. But this is not a case every time. And big or small, major or minor, there are always issues which require resolution or correction on site. How quick those issues can be completed and solved is crucial for on-time and smooth commissioning and startup. Based on our experience, all issues can be divided on a system type and non-system type issues, with relation of approximately 10 to 15% for non-system and 85 to 90% for system issues. The only area where this relation is a little bit different are the site piping and electrical installations. This area show more towards non-system issues. We will discuss all those later stage in this webinar. Non-system issues are those which appear sporadically and cannot be predicted, foreseen in advance. However, these issues can be eliminated during the proper vendor inspection, assuming that equipment is fully checked and arrives to site fully ready to be installed. These issues, as I mentioned, are about 10 to 15%. Although these issues are on a small percentage, but they are much more important, as even small issues can have a drastic influence on further activities and can delay further installation and commissioning. System issues are those which can be predicted based on a previous project's vendor evaluation, lessons learned, and contractors' evaluation for site activities. And these issues are somewhere between 85 and 90%. As a non-system issues, the following can be considered. For example, wrong connections are applied, This could be wrong flange size and location up to wrong cable connections and wrong cable size. Wrong painting is applied, or rather painting system or thickness. Wrong flange type is installed, or wrong material is used for construction of valves or fittings. And other system issues like valve leakage rate, incorrect wiring and cabling on equipment and skids, nozzle orientation and location on the vessels, tying point, vibration issues on rotating equipment, pump compressor, performance data, and not fully tested control system. On today's webinar, we will concentrate more on system issues and how to eliminate them. We will mention those issues later for each type of equipment. And one important thing, as I always mention, you don't get usually what you expect, but exactly what you inspect. Different approaches to project QA/QC affecting final results. There are three main approaches to organize and put together QA/QC team for project control of QA/QC activities. One is the QA/QC is sole responsibility for EPC contractor. Second one is when QA/QC activities are controlled in parallel with EPC and owner. And the third one, when there is an integrated team to control QA/QC activities. If each of above systems have advantages and disadvantages. The first approach is more common use during the lump sum and turnkey projects. In this case, all activities are fully controlled by EPC contractor, including inspection and expediting. In our experience, this approach leads to the situation when some operational topics are not fully controlled during the manufacturing stage and can be critical during the installation, startup, and commissioning, and even further for the operation. Of course, this is a less costly approach, but needs a final detailed verification on site when equipment arrives to site. As advantage, no additional cost for owner, less involvement by owner. As a disadvantage, owner has no control. Any changes on a QA/QC scope will be rather on a higher price. And sometimes this results on a low quality as the EPC contractor has very often low budget. Second approach is parallel coverage when both parties, EPC and owner, are fully involved in a QA/QC activities. EPC contractor has still full responsibility. However, proper input from owner operator side can be beneficial for final results. However, this is a very costly approach as all activities are actually doubled, and although that gives more complete results. And as an advantage, full control by owner, operational issues can be addressed and directly resolved, but higher costs for owner. And the third one, the integrated approach, which is kind of combined approach where all topics, including operational ones, can be covered. But this approach requires quite a complete management of the QA/QC team, as EPC and owner in some areas have different priorities. From the point of view of total cost, this is an approach in between the first two. Less cost from owner, more coverage in involvement as an advantage, and as a disadvantage, complexity of the management of the entire QA/QC team. Recently, I ran a poll on LinkedIn, and they showed that the parallel and integrated approach are more preferable, and both showed about 40% of the results That means the owner operator needs and wants to be fully involved on QA/QC activities throughout the entire project. And in our experience, the ideal approach is when owner's QA/QC team is fully dedicated only to the project. DCU major equipment and specifics in regard to QA/QC activities. We will talk about the major equipment of the DCU plant: coke drums, top and bottom unheading devices, main fractionator, coke cutting and conveying system, wet gas compressor, heater pump, pumps in general, piping, electrical installation, and plant control. Piping and electrical installation are very important because they showed more non-system issues, quality related, and these issues needs to be controlled and eliminated throughout the entire production. It doesn't mean that the remaining equipment is not important, but it's less critical in our experience of you in regards to the quality type issues. The topics discussed during today's webinar can be applied generally on all projects. However, DCU plant has some specifics. The main specifics for the DCU project equipment are that despite the complexity of the equipment, number of vendors is not very big. The same supplier, same vendors are involved on different projects due to licensor restrictions, for example. Therefore, it's very easy to evaluate the previous deliveries and all other issues. Furthermore, the issues can be evaluated and applied to the other vendor for the same type of equipment. Other important topic here is that the majority of main equipment is delivered at the early stage of the project and requires proper handling, installation before commissioning and startup. Equipment is delivered, as I said, in an early stage. Some of them are installed directly, some stored and installed at a later stage. And in this point, proper handling storage procedures are essential. Last but not least, small number of EPC contractors are involved on a different DCU projects. And this allows correct evaluation of the previous lessons learned for the specific EPC contractor. And the correct and in place procedure, inspection, delivery, storage, installation, verification before commissioning and startup is essential for eliminating any quality related issues. Combination of all above specifics put into checklist allow control of the supplied equipment from early stages, eliminating any potential QA/QC issues during the commissioning and startup. QA/QC matters and aspects affecting proper operation and asset integrity. The issues we discussed are mainly affecting installation, commissioning, and startup, but most of them or some of them are also very important for the operation and asset integrity of the plant. For example, pump compressor performance data, valve leakage rate, painting and installation on drums, columns, piping, heat and steam tracing, heat exchanger performance data, fractionator, tray supports, tray leveling. Just to name a few, all those issues have an influence on the proper operation and asset integrity of the plant. And just to name a couple of examples, for fractionator tray problems can cause a shift of yield and from design values and result in increased costs. Only 1 ton of additional steam requirement per hour will result another 120,000 additional US dollar cost per year. The same amount of cost will cause 200 kilowatt additional power consumption because of the not proper insulation of or electrical heat tracing. Not properly insulated process equipment can cause a very high OPEX and CAPEX costs. Of course, these calculations are on a very low margin calculation. In reality, they are much more higher on the real refineries. So therefore, proper checks are essential to have all these issues eliminated prior to the deliveries. Prevention measures and procedures, Goldilocks approach. Many EPC contractors use lessons learned to record any issues discovered during the site acceptance test, the factory acceptance test, incoming inspections and installation. This is for sure a great tool to prevent those faults from happening in future. But in our view, it does not cover the whole picture. We have developed overall procedure and checklist or complex evaluation of the equipment, vendor, site activities combination. As a final approach, checklist include also input from operator owner side, which will allow for complete checking of the equipment before delivery. When this graph shows the quality-related issues and how they can be eliminated with some verification efforts. Usually, the equipment is delivered on site on this point, and it has some remaining issues which appeared or discovered on site, and in that point, you have quite a big number or required big amount of efforts to rectify those issues. Whether this is a cost, resources, time, the efforts can be the combination of all. However, with same amount of efforts, you can eliminate those issues long before the delivery. We added some specific verification activities based on site issues in the past, as well as the amount and volume of the checks prior to delivery. So the material comes to site completely checked and conform to the project requirement. Also, as I mentioned before, input from the maintenance and operations are also included on those checklists. And this, in most of cases, creates the ideal case when after delivery, we do not have nearly any open issues, and also no further activities are required to correct them. We will go through those issues, main issues because of the time restrictions, main issues for each type of equipment, which needs to be properly checked prior to the delivery. Additionally, there is another topic or another issue to consider. Rough calculations show that DCU plant allows minimum $1 to $2 US profit increase per barrel. In average daily revenue, that will be 150 to 200,000 US for middle-sized refinery. And with this simple calculation, any day or any week of delay for startup of the plant will cause enormous loss of profit due to late startup. Coke drums. The major issues to be considered on coke drums are nozzle orientations and proper insulation. Additionally, the provisions for the insulation are very critical, as no further welding can be done on site easily. These verifications are added on a specific checklist and allow to check everything prior to the delivery, including including painting, including insulation. And very important is the verification of location of anchor bolts. This needs to be done properly during the manufacturing stage, because any adjustment on site will not be that easy to complete, and also anything which is not properly done during on the anchor bolts will result on a damage during the operation of the coke drums, and it will have, in a worst case scenario, that will lead to 2 to 3 weeks of delay. Coke handling system. For this equipment, it's very important to check every part of the system manufactured at the suppliers. Usually, several parts are manufactured at the different sub-suppliers, and they are only put together and assembled on site. So any adjustment, any changes which needs to be done on site will cause definitely double or 3 times more on efforts, which could have been checked and verified during the manufacturing stage. Important is the control routine. Usually, site acceptance test is a real-life functional checks of the control routine, and it takes a couple of weeks up to 1 month, as this test cannot be performed on a simulation mode. Therefore, proper checks at the vendor facilities are very important to leave as less as possible changes on site. Important is what we also experience, the installation of the instrumentation, which requires proper checks because that affects mainly on the functionality of the control routine. Top and bottom unheading devices. These items really went through major modifications. However, there are a couple of issues which needs to be properly controlled on this equipment. Regardless whether it's a single disc or double disc configuration, it's necessary to check the leakage rate. Because regardless, as I said, whether it's a single disc or double disc, discs are affected to the erosion because of the excess leakage. And very important is to check where leakage at the vendor facilities. If the leakage rate is somewhere, in our experience, 75% of the allowed API leakage rate, this needs to be checked properly, because this will go up definitely during the operation. Also very critical, very important are the leakage areas, as the discs are affected. Some areas of the disc are more affected on a leakage due to thermal deformation during the operation. Very important are the purge connections, because nothing can be changed or adjusted on site because of the welding cannot be performed that easy on site. For the control routine on a local control, what we experienced, important thing is the interlocking checks between 2 drums. Next part is main fractionator. These items has own specifics in regards to QA/QC activities. In majority of cases, the column itself and internals are produced at the different vendors. So each one is responsible for his own activities, and the merging of the column and the internals is performed on site. And in some of cases, if adjustments are needed to be done on site, this takes several weeks to complete. This could cause us a delay also on a mechanical completion. but in the same time have some influence on the operation of the fractionator. The other important issue is the verification of the installation pattern. We experienced a case when the installation pattern was not fully checked, and it took a couple of weeks to adjust everything on site. Connection points and time points for the fractionator are very important. And last but not least, the applying of the insulation, proper insulation painting, as this will protect from the corrosion under insulation. Next system is co-cutting system. This system is very complex and really require very detailed attention. These have several reasons. Equipment is being manufactured at the different places and different locations. Very often it's being delivered directly from sub-supplier to site. So final assembly is done, which is more important. Any misalignment can only be corrected on site. Furthermore, location and the area of this system requires all the valve leakage to be checked properly. There were cases recorded when the leakage of the valve caused even the damage of the coke drum insulation. Proper verification again of the control routine. This system can be only fully checked on site after complete installation, and therefore detailed check at the vendor premises, at least in a simulation mode, are very important. Wet gas compressor. We did not experience much problems with the installation and commissioning startup of the compressors, but special attention to be drawn to connection point, the main connections, inlet outlet, and also the auxiliary connections for the lube oil system, seal gas system. Also important thing is control panels and control routine. Control panels cannot be rewired and rearranged easily on site, and control routine is usually checked separate from the compressor. So detailed checks are very important to avoid any delays. We have the golden approach generally on the control routines for all systems, which says as much as possible at the vendor premises and as less as possible left for site verification and site arrangements. Heater pump and pumps in general. Heater pumps in generally all pumps on a project, on a plant, are less affected and after delivery issues. However, some of them can cause long correction times up to replacement of some part. Very important are the connection issues where inlet outlet, again, lube oil sealing system, steam jackets, especially for the heated pumps, are very important. Also very important is the vibration issue, as testing at the vendor facilities is a bit different from the site conditions. There were recorded cases when vibration checks were performed at the vendor without problems, but we experienced the vibration problems on site. So again, here we have the standard approach when the vibration limit is when the vibration level is somewhere 70 to 75% of the allowed limit. This should trigger much more detailed attention. So the site piping, as I mentioned before, this is a very important and very complex issue. This is a really very complex task which require proper coordination and probably the highest level of the QA/QC involvement. It has several reasons, but the main thing is that 3 different parts and 3 different vendors are involved on the entire. One is the fitting and pipe manufacturer. Second is the prefabrication shop and the site installation. The main issue here is the complete verifications at the vendor, proper welding inspections, and amount of NDE at prefabrication shop site activities, including heat tracing and insulation. There's a complex task, and whichever is missed in any stage will really cause enormous delay during the correction and if you start to rectify this. Also, several activities are running in parallel and proper coordination is essential. So I mentioned here the major issues which we experienced throughout several projects. Electrical installations. These activities are running mainly in parallel with piping and the installation of the main equipment, and very often overlap those. Delays on one part, for example, piping, will cause a delay on electrical installation and vice versa. Another important thing on the electrical installations is that the amount of the junction boxes, cables, underground and overground are very big. And even small issue overlooked can cause us several weeks time and big cost and efforts to rectify. And here I want to mention also a very important thing is grounding. This involves not only design, but also authority, fire safety, and explosion safety requirements. And to correct even on one place the grounding throughout the entire plant installation, this will be definitely for a couple of months job. Anti-plant control. This is also one of the most complex issues. The major difficulty here is that none of the subsystems can be fully tested at the vendor facilities, as they need to be adjustment and finalization on site. Maximum what can be done at the vendor communication test with respective SCADA or DCS system. Detailed verifications are necessary at vendor facilities for each subsystem, including full simulation tests. Integrated FAT is essential prior to the delivery to site. As less as possible points needs to be left for the setup and adjustment on site, and as much as possible time to be spent for checks at the vendor facilities. Also, very important is the hardware issue. As any changes on a hardware, this could cause enormous efforts and delays to correct them and retest of the entire system. So as a conclusion, all those mentioned problems and delays not always accumulating throughout the project, but in some cases created difficulties for the further activities, increase OPEX and CAPEX costs. Above simple calculations show that even 1 month of late startup of the project would cause a significant loss of profit compared to the overall project cost. Above issues were discussed for new plant commissioning, but this is very important for revamping projects and changing of the single equipment on a plant, because all these activities are happening on very small window and the margin is very short, and any delay on those issues can cause not only late startup of the DCU plant, this will also cause a delay on the entire startup of the plant. So that was it. Thank you very much for your attention. Back to you, Becky.